Good morning, good afternoon, good evening, everyone, and here's for the second part of our video, Bedmas with fractions. Now, just like we said in the other video, Bedmas, you're always going to go in the order of the BEDMAS. Now, with fractions, you only add one additional step, and I'm going to show you what I mean here. So, let's go with an easy example here. So, let's say you go example 1. And let's go with, let's go with 2 minus 6 over 5 plus 1 over 2. Now, in this example, you only really have to deal with minuses and plus, but there is a bracket. Now, if we're using the box method from the last video, the box would go clearly around this bracket. And of course, this 2 by itself. Now, inside the bracket, so if we go to our next line here, this 2 comes down. You have 6 over 5 plus 1 over 2. You can't add the fractions together unless the number on the bottom is the same. So on the bottom, we've got 5 and 2. We don't know what number we want to turn them into. Let's say you have trouble with your times tables. It's perfectly fine. On the side, you can write your two numbers. Let's write down 2 and 5 and do yourself what we call a factor table. Okay, so what a factor table is you basically write out the multiples of the numbers. So we got 2, 4, 6, 8, 10, 12, and da-da-da-da-da. And for 5, we've got 5, 10, 15, 20, and da-da-da-da-da. And when you look at your table, you then say, when are they both the same number? Well, they can both turn into 10. Again, obviously, when the numbers are very small like this table is not useful, but when the numbers get bigger, it definitely helps out. The better you are with your times tables, the quicker these go. So I know I can turn them both into 10. How do I turn 5 into 10? I multiply it by 2. But remember, in mathematics, it's kind of like when you have a brother or sister, and if you get $10, they're going to want $10 too. It's the sibling rule. So we can't just multiply the bottom by 2. We have to multiply the top by 2 as well. Same thing here. Here, for 2 to turn into 10, I need to multiply it by 5. Same thing to the top. Okay, so when we do that inside my bracket, I now am going to have 12 over 10 plus 5 over 10. Now, they're the same number on the bottom. So now that they're the same number on the bottom, I just know I'm going to be able to add our tops here. So we've got 12 plus 5, which is 17 over 10. Now, because the addition's been made, I don't need the bracket anymore. The bracket's gone. So let's get rid of this bracket. Now, the bracket is useful if, let's say, in the end here, I had a negative number in here. I already had a negative out here. These negatives would apply, giving me a positive. But we don't have that issue here. We just got the minus. But once again, I've got a number minus a fraction. You can't add these numbers together unless they have the same bottom. Now, I know people are going to say, like, the number 2, it doesn't have a bottom. But it does. Remember, even if you don't see it, every number can say that it's being divided by 1. Because 2 divided by 1 is still 2. So it does have a bottom. And I got to turn that bottom into 10. And that's easily done by just multiplying by 10. Same thing to the top. All right, so that gives you 20 over 10 minus 17 over 10. Let's do this subtraction. You've got 3 over 10. Now, in your last step, usually, you would be looking at your fraction and asking, is this the smallest fraction I can do? Thankfully, it is in this case. The number on the top is also smaller than the bottom, so it's not an improper fraction that needs to be turned into a mixed fraction. So this is your final answer. Okay, so let's do something a little bit harder. So for example 2, we're going to keep stepping it up with difficulty. Let's go with 3 over 2 divided by 1 over 2 plus 5 over 3. Now, once again, you've got fractions. You don't want fractions. You want to have the same bottom on the bottom. So I've got here 2 and 3 on the bottom. I can turn them into 6. I can do that by multiplying this by 3, and this by 3, and this by 2, and this by 2. I can also do the same thing with the fractions on the outside, but it's kind of useless. I'm only doing that here because of the addition symbol. Okay, so 3 over 2, not touching it, divided by. Now inside I've got 3 over 6 plus 10 over 6. Sorry, technical issues. And then you've got 3 plus 10, so this is going to turn into 3 over 2 divided by 13 over 6. All right. Now, when you got the division, you got to remember the division rule when it comes to fractions. You don't care about the first number. But in the second one, we can bring the top to the bottom and the bottom to the top, turning this into 6 over 13. And when I do that, instead of division, it now turns into multiplication. Shocking. So we do our straight up multiplication here. Let's do that. I'm going to continue over here for more room. So I've got 3 times 6. Now when we do a multiplication, remember the top multiplies the top, the bottom multiplies the bottom. So 3 times 6 is 18. 2 times 13 is 26. Now, just like I said in the first example, when you look at your final fraction, you got to first ask yourself, is this the smallest it can go? And in this case, no, it's not. And I know that by asking, can I divide the top and the bottom by the same number? Well, in this case, I definitely can. I can divide the top by 2, and I can also divide the bottom by 2. Which is going to give me 9 over 13. This can't get any smaller, so this is your final answer here. Always remember to simplify fully. Reduce your fraction to the smallest it can go. Now, in the last example I'm going to do here, I'm going to try to build up the difficulty and try something a bit harder to show you how all the methods work in one. And hopefully we can go around with that. So in this last example, let's try this one out. So example 3, this one is a little bit harder. If this was an exit ticket, this would be something called a spicy level question. So we have 6 minus 13 over 7 divided by 11 over 8 minus 10 over 9. Now, I could make this harder by adding square roots, by adding exponents, by dividing this by something, but all that I'm doing is making it more tedious. Really, it doesn't really matter what your numbers show. It doesn't change your steps. Now, once again, I've got a 6 here. Remember, it's the same thing as saying 6 over 1. Why do I care about that? Because there's a minus here. And remember, our old rules, brackets are together. So when I do that, I need to turn the bottom into 7. So I'm going to multiply it by 7 and the top by 7. So my next line, I'm going to come down, and in my bracket, I'm now going to have 42 over 7 minus 13 over 7. And of course, this is divided by 11 over 8 minus 10 over 9. And before someone says, well, why don't we just do this subtraction? You can't. Remember, this division means I can't touch this 11 over 8. This one is attached at the hip with this bracket. So let's continue this. So now I'm going to finish this off, this bracket. So 42 minus 13. If you have trouble doing bigger numbers in your head, try breaking it down to paces. So instead of doing 42 minus 13, do 42 minus 10, which is 32, and then do that 32 minus 3, which is 29. So I know it's going to be 29 over 7. That's just a little trick to deal with the bigger numbers. All right, and then you add divided by 11 over 8. Now, we can do 2 steps in one here. As you get better in mathematics, you can start to, like be more confident with what you're doing. And that means doing more things at once. So I know that there is division here. So I know that when I'm dividing two fractions together, I can automatically flip these numbers. And this now becomes multiplication. This still stays as subtraction. Okay. Now let's do it. So you've got your multiplication here. Now you've got 29 times 8. And you've got 7 times 11 on the bottom. So on the bottom, 7 times 11, that's going to give you 77. 29 times 8 is 232. Gonna make that look more like a 3. There we go. Minus 10 over 9. Now, obviously, this wouldn't be a question I would give you on a test. Mainly, if you're allowed using your calculators, sure, but it gets a little bit more difficult when you can't use your calculators, but it is still very doable. You want to ask yourself, first and foremost, can I make these things smaller? You can't, so you have to straight up, first of all, you have a subtraction, so you need your bottom numbers to be the same. So you can just straight up do 77 times 9, do that to the top 2, 10 times the 77, same thing on the bottom, and we know right away it's going to turn into the same number on the bottom now. So you got 232 times 9, that's going to give you 2088. And then you've got 77 times 9 on the bottom, which is 693. So we know there's going to be 693 here too. And then 10 times 77, which is 770. All right, so you're going to do your subtraction now. So you've got 2088 minus 770. You got 1318 over 693. Okay. Now, when I look at this, can I make this smaller? Well, let's try to think. Could I divide the top and the bottom by the same number? Well, let's try our prime numbers. So if I divide by 3, nope, doesn't work. I know 693 is divisible by 3, but 1318 is not. I definitely can't divide the bottom by 2, so even if I can divide the top by 2, it doesn't work. So at the end of the day, we have a fraction where the number on the top is bigger than the bottom. So we're going to turn this into a mixed fraction. So to know that, you're going to have to ask yourself, how many times does 693 go into 1318? So think of it this way. Let's say you have a pizza and I cut my pizza in 693 slices. It's hard to imagine, like you've got your pizza here and I cut it in 693 slices. It is possible. I don't know if you can make a pizza with cut in 693 slices, but let's think about the pizza. Can I have over 1,000 pieces of that 693? No, it doesn't make sense. So you have to ask yourself, I'm going to move on to the next pizza. I ate at least one pizza. Now, 693, double of that is more than 1318, so I know I can at least fit one whole pizza, and then what's left over, do the difference. Do 1318 minus 693. Sorry, technical difficulties. And you're going to get 625 out of the 693. So you ate most of the other pizza as well. And that would be your final answer. I hope that you have learned how to use Bedmas in various ways here with fractions. And remember, like Bedmas, the steps don't change even if the numbers get bigger. You just have to chunk it, do it step by step, and you will eventually reach your final answer. Have yourself a wonderful day, and good night.